So in this video, we're going to talk about the types of solids that you may encounter in chemistry. And we typically call these crystalline solids. And we describe crystalline solids based on what they are made out of. So they can be made out of molecules, ions, or just atoms. And if they're made of just atoms and they're called atomic solids, then we further classify them based on if their interactions are non-bonding interactions, metallic interactions, or covalent interactions. So here we have a chart of all the types of solids that you can have, and we're just going to go through this chart one by one. So we start with molecular solids, where your particles are molecules held together by non-covalent interactions. Therefore, you have low melting points like in ice. Then you have ionic solids, which are made out of ions, cations and anions, held together by electrostatic forces, so you have very high melting points like in salt. Then for your atomic solids, you're made out of atoms, so you can have non-bonded atomic solids, which are held together by very weak forces, so you have very low melting points. Metallic atomic solids, which are metals held together by metallic bonds, and based on the metal, you'll have different melting points. And then you have covalent atomic solids, which are held together by covalent bonds. Covalent bonds are very strong, so they have high melting points. So let's look at these categories a little more in depth. We're going to start with molecular solids, like I said. These are made out of molecules, some examples being CO2, H2O, C12, H22O11, right? And so since there's no covalent bond between molecules, for example in ice, two different H2O molecules are not covalently bonded together. Rather, they're held together by intermolecular attractive forces. Remember, the word inter means different molecules. And these forces could be dispersion forces, dipole-dipole, or like in the case of water, hydrogen bonds, right? Since these are just attractive forces, these are weak forces, and so these solids aren't strongly held together, so they have relatively low melting points. And for molecular solids, they can actually form crystals different ways. These different ways of forming crystals are called polymorphs. And these polymorphs can have different properties. And this is very important when it comes to pharmaceuticals, as different drugs can have different properties based on the crystal structure they're in. But the example we have here is cocoa butter, where we have 6 different types of cocoa butter that can form. And based on how they crystallize, you can have different melting points and different textures of your cocoa butter. So the next type of solid we have are ionic solids, and these solids are made out of ions. And they're held together by these strong Coulombic forces, and Coulombic forces just means electricity, electrostatics. You have a positive and negative ion together. They are held together very strongly. Since this is a very strong force, they have very high melting temperatures. For example, table salt, if you put table salt on your stove, it's not going to melt because that solid is held together very strongly. Then we have atomic solids, which are made out of atom, and we have 3 different types. The first are non-bonded atomic solids. So these are only held together, the atoms are only held together by dispersion forces, very weak, and so you have very, very low melting point, way below room temperature. So your noble gases, if you lower the temperature enough, they become a solid, and they are only held together by dispersion forces. Then we have metal atomic solids, which are made out of metal bonds. A metal bond is simply you have all your metal atoms aligned, and then they share all their electrons. You have a sea of electrons just washing over all your metal atoms. And so these metal bonds can be strong to extremely strong depending on the type of metal you have. So variable melting points, but you get a very close-knit bunch of atoms through a metallic atomic solid. Then you have your network covalent solid, where all your atoms are held together by covalent bonds. Since these are all held by covalent bonds, the strength of these interactions is very strong, and so these solids have very high melting points, right? And that's it for this video, and I will see you in the next video.